Have you ever looked up at the night sky and wondered, what's out there? The vast expanse above us is filled with countless stars, planets, and mysteries waiting to be uncovered. It's a question that has fascinated humans for centuries, sparking curiosity and imagination in both young and old alike. It's a question that people have been asking for ages. The universe is a huge and mysterious place. Imagine a space so vast that it stretches beyond our wildest dreams, filled with billions of galaxies, each containing millions or even billions of stars. It's a place where the laws of physics as we know them can sometimes seem to bend and twist in the most unexpected ways. It's full of stars, planets, and things we are only beginning to understand. Luckily, we have amazing scientists like Stephen Hawking to help guide us. These brilliant minds dedicate their lives to unraveling the secrets of the cosmos, using powerful telescopes and advanced technology to peer deeper into space than ever before. He loved thinking about the biggest questions ever. He wrote a book to help explain the universe to everyone. Stephen Hawking's work has inspired countless people to look up at the stars and wonder about the nature of our existence. His book, A Brief History of Time, became a bestseller and brought complex scientific ideas to the general public in a way that was both accessible and engaging. In this book, Hawking talks about things like the Big Bang. That's the idea that the whole universe started from a tiny point. Imagine all the matter and energy in the universe compressed into a single, incredibly dense point, which then exploded outward, creating everything we see today. This monumental event set the stage for the formation of galaxies, stars, and planets, including our own Earth. Can you imagine that? He also talks about black holes. These are places in space where gravity is so strong that nothing, not even light, can escape. Black holes are formed when massive stars collapse under their own gravity, creating a point of infinite density known as a singularity. The gravitational pull of a black hole is so intense that it warps space and time around it, creating a region known as the event horizon, beyond which nothing can return. The universe is full of incredible things, and the best part is, we are still learning about it. Every day, scientists make new discoveries that challenge our understanding and open up new possibilities. From the search for extraterrestrial life to the study of dark matter and dark energy, the quest to understand the universe is an ongoing adventure. So get ready for an adventure as we explore some of the coolest ideas in the universe. Whether it's the mind-bending concepts of quantum mechanics or the awe-inspiring beauty of distant galaxies, there's always something new to discover. So grab your telescope, put on your thinking cap, and join us as we journey through the cosmos, seeking answers to the biggest questions ever. Before the universe, there was nothing. No space, no time, no stuff. It's hard to even think about, isn't it? But then, something amazing happened. All the energy of the universe was packed into a tiny, tiny ball. It was smaller than a grain of sand. It was even smaller than an atom. This tiny ball was incredibly hot and dense. It was like a super-duper compressed spring ready to burst. And then, it happened. The Big Bang. The tiny ball of energy exploded with unimaginable force. This wasn't an explosion like fireworks, though. It was the expansion of space itself. The Big Bang wasn't just an explosion of stuff into space, it was the beginning of space and time themselves. As the universe expanded, it cooled down. Energy turned into tiny particles like the pieces of a giant Lego set. These particles came together to form atoms, the building blocks of everything we see around us. Over billions of years, stars and galaxies formed. Planets like our own Earth came into being. And on our planet, life arose. It's pretty amazing to think that it all started from that tiny point smaller than an atom. The Big Bang is still happening today. The universe is expanding, getting bigger and bigger all the time. Imagine you could ride on a beam of light. You'd be zooming through space at the fastest speed possible. Nothing travels faster than light. It's like the universe's speed limit. Light travels incredibly fast. It can go around the entire Earth over 7 times in just 1 second. But even at that speed, it takes time for light to travel through the vast distances of space. When we look at the stars, we're actually seeing light that left them a long, long time ago. Some stars are so far away that their light takes millions of years to reach us. Section 5. Faster and faster. Can we beat light? We know that light travels incredibly fast. But what about us? Could we ever build a spaceship that goes faster than light? That's where things get really interesting. According to Einstein's theory of relativity, nothing with mass can travel the speed of light, let alone faster. It's like trying to run through a brick wall. As we approach the speed of light, strange things start to happen. Time slows down and objects get heavier. It's like the universe is telling us, nope, not gonna happen. Section 6. Black holes, where gravity plays tricks. Black holes are one of the most mysterious and fascinating things in the universe. They're like giant cosmic vacuum cleaners, sucking in anything that gets too close, even light. Black holes are formed when massive stars collapse at the end of their lives. Imagine a star much bigger than our sun, squeezed into a tiny space. The gravity becomes so strong that nothing can escape. It's like a bottomless pit in space. We can't see black holes directly because no light can escape from them, but we can detect them by their effects on nearby stars and gas. Have you ever wished you could travel through time? Well, according to Einstein's theories, time travel might actually be possible, at least in theory. Einstein's ideas about gravity and time are pretty mind-blowing. He said that gravity isn't just a force, but it's actually a warp in the fabric of space-time. Imagine a bowling ball on a trampoline. It creates a dip, right? That's kind of like what massive objects do to space-time. And just like a marble rolling around the bowling ball's dip, objects and even light follow the curves of space-time caused by gravity. Now about those time warps. Some scientists believe that extreme warps in space-time called wormholes might exist. Think of a wormhole like a shortcut through space and time. If we could find or create a wormhole, it might be possible to travel vast distances across the universe or even journey through time. However, there's a catch. There's always a catch, right? Wormholes are purely theoretical at this point. We don't have any proof that they exist, and even if they do, they might be incredibly unstable and dangerous to travel through. Stephen Hawking spent his life exploring the biggest mysteries of the universe. He wasn't afraid to ask big questions, even if the answers seemed impossible. Hawking's work has inspired countless scientists and dreamers to keep exploring the cosmos. His book, A Brief History of Time, is a testament to his passion for sharing the wonders of the universe with everyone, not just scientists. Even though he faced incredible challenges in his own life, Hawking never stopped looking up at the stars and wondering about our place in the grand scheme of things. As we've journeyed through some of the most amazing ideas in astrophysics, one thing is clear: the universe is full of wonders waiting to be discovered. From the mind-boggling scale of the Big Bang to the mysteries of black holes and the possibilities of time travel, there's so much to learn and explore. So the next time you look up at the night sky, let your imagination run wild. Ask questions, seek answers, and never stop exploring the vast and incredible universe we live in. Who knows what amazing discoveries await us in the future? Maybe one day, you'll be the one to unlock the secrets of the cosmos.